Good morning, everyone. How are you all doing out there? Hope you are doing well and staying safe. My name is Cara. I am the Wildlife Ambassador Manager here at Reptile Encounters, and today we are going to bring you a little sneak peek into our body and organ systems show. So just while we're waiting for a few people to join us, just going to put a few reminders out there for you all. Make sure you have notifications turned on for all the wild live streams coming at you from the Reptile Encounters Facebook page. Up in the corner, there's 3 little dots. Click on that, select notifications. Make sure you are getting informed about when we are going live. Please also make sure you are liking and following Reptile Encounters on Facebook, and also liking and subscribing Reptile Encounters YouTube channel as well. We've got lots of content going up on our YouTube channel. Make sure you are subscribed to that as well for all of the fun. So for those of you who have just joined us, my name is Cara. I'm the Wildlife Ambassador Manager here at Reptile Encounters, and today we are doing a little sneak peek into our body and organ system show. Faye, do we have any people saying hi yet?
We don't, but we have a few watching.
Excellent. Hello to everyone who is watching. Please say hi in the comments. We love finding out who is tuning in. And as we go through the show today, please write any questions in the comments. We'll try and answer them as we are going live. But if we don't quite get to you, I will make sure to jump on those comments later and reply to you all personally as well. So the Body and Organ System Show is one of our secondary school shows that we do here at Reptile Encounters, and usually we do this for our Year 8s as it fits in really nicely to their body and organ systems topic in the Victorian and Australian curriculum. So for any teachers who are watching out there, you can still book a school incursion for later in the year for when it's safe for us to come back into your classroom, or if you need something a bit sooner, Reptile Encounters is doing our wildlife streams online, so you can stream directly into your classroom and also to any students who are learning at home. So please give our office call 1300 4-CROCS if you want to find out any more information about our wild live streams incursion program.
We have a few people saying hello. We've got Corey, we've got James, we've got the Woodlands Kinder who's here as well, and
hello.
we have Nasa.
Excellent. Thank you so much for joining, everyone. This is going to be a lot of fun. So normally when we do our body and organ system show, like all of our incursion programs, we bring out a variety of different animals and we talk a little bit about them. So for the body and organ systems, we'll talk about their cardiovascular system, their respiratory system, their digestive system, maybe their nervous system, and maybe a whole bunch of other organ systems as well. There is a lot to cover. We have lots of different organ systems in our bodies. But today I'm going to do something a little bit different. I'm just going to focus on the cardiovascular system. So I wonder if anyone out there can put in the comments what the main organ in our cardiovascular system is. I'll give you a hint. It sits in our chest, right about there, and it beats, it pumps. And this organ pumps blood around our body. And inside the blood is lots and lots and lots of stuff. So we have oxygen in our blood, we have carbon dioxide in our blood, we have immune cells in our blood, we have nutrients, we have hormones, there's even waste products in our blood, because the blood is the fluid that moves all the way around our body and moves all the things to where they need to go. Has anyone had a guess in the comments yet what the main organ is?
We've got heart.
Well done! It is the heart. So the heart is the main organ of the cardiovascular system, also known as the circulatory system as well. So I'm going to start off today with a mammal. So just like we are mammals, I have my little friend Coda here, who's just popped out of his little pouch. Do you want to hop back in there so you feel nice and cozy? Good boy. So this is Coda. Coda is a woylie, and he is a mammal just like us. So that means he has hair on his body. We've got hair on our heads. Some people more than others. He drank milk when he was a baby, so just like we drank milk from our mums when we were babies. And he is warm-blooded, also known as being an endotherm. And that means he regulates his body temperature internally. And he has to maintain a homeostatic internal environment to make sure he's got enough energy to do all the things he needs to do and also maintain that body heat. And one of the important things that helps to maintain that homeostasis, to maintain that endothermic internal system, is the way the heart is formed in the mammals. So for mammal hearts, looks a little bit like this. We have 4 chambers in our heart. We have 2 atrium, they're the ones at the top, and then we have 2 ventricles, so they're the ones down the bottom. So a nice easy way to remember that: atrium at the top and ventricle down the bottom. So it looks like a V, looks like an A. So that's the really good way to remember it. Now when we get oxygen, that comes from our lungs, but it has to get into our circulatory system. So the oxygen will come in from, it's very hard to look at this upside down. Should have practiced this more, shouldn't I? It will come from our lungs and then go into the left atrium. Then it will go down into the left ventricle. Then it will go up through the pulmonary artery and then go off to the body to make sure all our body cells have plenty of oxygen to do all the functions that they need to have. In return, the deoxygenated blood will come back from the body, either from down this direction or up that direction, back into the right atrium, through the right ventricle, and then off through the pulmonary artery to the lungs. In that process, the carbon dioxide will go into the lungs to be exhaled, and more oxygen will be breathed in to then go back to the heart, go back to the body, and the cycle continues and continues and continues. So in mammals, we have what's called a closed circulatory system. So everything is contained within that system. Am I boring you, Coda? You look like you're going to sleep, mate. Now, mammals are not the only animal to have a 4-chambered heart. So we're going to let Coda back to sleep because he is nocturnal and he would much rather be asleep right now, and I cannot blame him for that. So we'll put little Coda away. And then I'm going to get out an animal that has feathers. And she is also nocturnal, but hopefully she might be a little bit happy to be awake compared to Coda. Step up. Good girl. Oh, you're very excited. Hello, Gladdy. This is Gladdy, and she is a barn owl. Now, both birds and mammals are endotherms. They are both warm-blooded. They both have high metabolic rates, and they need to have lots of energy to do all the activities that they need to do and also maintain that warm-blooded internal body system. So, the bird heart is very similar to the mammal heart. It also has 2 atriums, 2 ventricles, so 4 chambers. And that's really important to keep the oxygenated blood and the deoxygenated blood separate so that the right blood, oh, was that a bit close?
No, honey.
Didn't want a close up there, Gladdy. Very important to keep the blood separate so it's going to the right spot. You want to make sure the oxygenated blood is going to the body because the cells need that oxygen, but in return you want the deoxygenated blood to go back to the lungs because it needs to get more oxygen to then go back to the body. So that's really, really, really important. Now with birds, they need to maintain a very, very, very high metabolic rate because what can they do with those lovely wings? They can fly. You're not going to fly too far away though, are you? You're attached to me. So you might notice on Gladdy's legs there, she does have some little leather straps. She also has this little attachment called Jess's, and that means she is attached to me and she cannot fly away up into the rafters, which is probably where she would like to go and then go back to sleep. Barn owls like to perch very, very high. But if you go up there, we can't get you back down, can we? No, we can't, so you're attached to me. I'm sorry, love. All right, I won't pat your head. Now, because birds have such a high metabolic rate, their cells also will produce lots of waste products, and that waste product will go into the blood. So by having a very, very fast circulatory system, they're able to flush out those waste products so the birds don't get sick, which is very, very important. It's also one of the reasons why birds poop a lot. Have to get those waste products out of their bodies. Have we had any questions so far, Faye?
No, we've had that's very cool, very interesting. Lots of people are enjoying this.
Excellent. Well, we're going to move on from some warm-blooded animals to some cold-blooded animals, also known as ectotherms, which means you can go back to sleep, Miss Gladdy. How exciting is that? So excited. Back into your box. Good girl. Back to sleep. Excellent. So, the first ectothermic animal that I'm going to introduce you today is an arthropod. So an arthropod is an animal that has jointed limbs. It also has segmented body parts and an exoskeleton that's made out of chitin. And this arthropod has 8 legs. So it is an arachnid. She is over here. Oh, there she is. This is Wendy. And Wendy is a northern tarantula. Now, it might surprise you guys to know spiders do have hearts. They are very kind little individuals. They actually do a lot of good stuff for us. They eat bugs. They love eating bugs. So if you have lots of bugs in your house and you see a lovely huntsman or a lovely daddy longlegs sitting up in the corner of your bedroom wall, I suggest you give it a name. Remember that it does have a heart and it's actually trying to help you out. Better to have one spider than hundreds of bugs. Now, you will not find the northern tarantula in your house down here in Melbourne unless you've had a pet one that has escaped, because these are a northern species of spider. So they are found up in the northern parts of Australia. They like it to be nice and warm. Now, a spider heart is very different to a human, mammal, or bird heart. Spiders have a tubular heart, and it runs across the back of their body. It's a dorsal tubular heart. It does still pump, but arthropods, so that's arachnids, spiders, scorpions, even insects, they have what's called an open circulatory system. They don't get oxygen from their lungs because they don't have any lungs. They get their oxygen from just the air. All across their exoskeleton, which is around the outside of their body, there's little holes called pores, and the oxygen just seeps directly into their bodies by these little pores that are called spiracles. But that goes straight into the body. So why do they still have a heart? Because remember, the blood has other stuff as well. They still have all those immune cells, they still have those hormones, they still need to transport nutrients around their body, and they have to get rid of those waste products as well. Now, the tubular heart, it's very, very small and skinny. It does still pump. It's more like little wave action, but it's not as strong as our human heart or a mammal heart or a bird heart. So that pumping action alone will not get the blood to the very ends of their legs. So arachnids, as well as insects, so spiders, scorpions, insects, they have to move to make sure their blood reaches the ends of their bodies. Because those little toes, they need to have the blood just as much as the body does. So the heart pumping moves the blood around, but also the legs moving moves the blood around. Now, a really interesting fact about arthropods, their blood is not actually called blood, because what we think of as blood is moving the oxygen around the body. But of course, that doesn't happen in a spider. So the blood of an arthropod is actually called hemolymph. So a little fun fact for you out there. We will let little Wendy have another rest so she's not disturbed by us any longer. She does like to be a restful spider. And remember, spiders have a heart. They are lovely animals. If you find one in your home, give it a name, make it feel part of the family. All right, Wendy, you can pop over here. And we're going to move back to some vertebrates, so animals that do have a backbone. Still on the ectotherms though, so cold-blooded animals. We're going to meet an amphibian. We're going to meet two amphibians in fact. If you'll come out of the little box. This is Kermit. And this one is Miss Piggy. 10 points to anyone who can guess where we named our frogs from. We love the Muppets. The Muppets are great. So Kermit and Miss Piggy are green tree frogs. These are Australian green tree frogs because there's lots of tree frog species around all over the world that are green. So these are Australian green tree frogs and they're found up in northern Australia. They like to live where it's lovely and warm and tropical, like to live in the rainforest, which helps them to camouflage with their lovely green skin. Now, an amphibian heart is a little bit different to a mammal or a bird heart. It doesn't have 4 chambers, it has 3 chambers. So an amphibian heart will have 2 atriums, but only 1 ventricle. So that poses a little bit of a conundrum. Amphibians, their blood will mix a little bit. So the oxygenated blood and the deoxygenated blood will mix. So that's not always a great thing because you want to make sure the oxygenated blood is going to the body and the deoxygenated blood is going back to the lungs. So what amphibians' hearts have, can you see those little grooves along the bottom of the ventricle? They are spongy walls. There's also, it's a bit tricky to see on this diagram, but there's also a spiral valve. And those spongy walls and the spiral valve help to make sure that the blood stays as separate as can be. So as the heart pumps, as it constricts, the deoxygenated blood might get sucked into those spongy walls and the oxygenated blood can get pumped out and then vice versa. So that means as best as an amphibian can do, the right blood is going to the right parts of the body. Now amphibians also get their oxygen a little bit different to you and I. Frogs are able to breathe through their skin as well as in their mouth and nose down into their lungs. So that means their circulatory system has to pass through little capillaries that run across the skin so the oxygen can be absorbed through the skin and also carbon dioxide can be released through the skin. Frogs get most of their oxygen by breathing in through their mouth and nose like us. They expel most of their carbon dioxide through their skin, but they will do both things both ways. So still some carbon dioxide will get breathed out and still some oxygen will get absorbed by their skin. So I think that's really, really, really cool. Very, very cool little creatures. But I have some reptiles for you guys to meet today. We can't be reptile encounters and not show you some reptiles. So Kermit and Miss Piggy, you can hop back into your little container. These little frogs do not live in here, of course. They have a nice big tank. If you want to see what it looks like, you need to go through our videos on Facebook and on our YouTube channel and find our frog spotlight with Tia. See where the green tree frogs live. Let's meet a snake though. So, hello gorgeous, you're ready. This is Sparkles. Whoa. Can someone grab my owl who's just escaped from the box? That's the rattling you can hear behind us. Good job, thank you, Michael. This is Sparkles. Sparkles is a diamond python and of course is a type of snake. Now reptiles, they have a heart that is a little bit similar to amphibians. They also have 3 chambers. So they also have 2 atriums and 1 ventricle. But reptiles, you could say, are a little bit more evolved than amphibians. So back in through the millions and millions of years of animal evolution, there's a common ancestor between amphibians and reptiles, and then they split off to have the amphibian branch and the reptile branch. So there is a common ancestor, so that's why their hearts are a little bit similar. But instead of having these spongy walls, there is a septum that is, you're going to point out for us, thanks Sparkles, there is a septum that separates the ventricle almost into 2 parts, but it's not a complete separation. And what will happen with the snake heart is as it pumps, that septum will shift to make sure that the deoxygenated blood will go out to the heart, out to the lungs to get more oxygen, and then the oxygenated blood will go out to the body. So I think that's really, really fascinating. Would you like to point it out for us, Sparkles? What's that? Is that the camera? You are not afraid of a close-up like Laddie was. Now, we did have a really good question in yesterday's wildlife stream, and that was with Dan, and he was talking about adaptations. And the question was, where is a snake's heart? And that was a really good question. So all the organs that are inside our bodies are pretty much the same inside snakes. They are just lengthened. So our heart is in our chest, about here. A snake's heart is about here, roughly. And it is a little bit elongated compared to ours. I know in the diagram they've made all the hearts look exactly the same, and that's just so it's easily visualized, but their heart is a little bit longer because their body is long and skinny. The heart needs to fit in that shape as well. Now, Sparkles, as pretty as you are, we've got one more animal for you guys to meet today. And the final animal today is a crocodile. And we have to move things around just a little bit. This is Charlie. Charlie is a saltwater crocodile. He is about 15 years old, give or take, and he's my favourite saltwater crocodile here at Reptile Encounters. He's also my friend Jess's favourite crocodile, so shout out to Jess if you're watching. I'm sure little Charlie misses you a lot. Now, crocodile hearts. They are reptiles. So that means they do still have 2 atrium, 1 ventricle, but the septum pretty much separates the ventricle into 2. It's so close from separating it fully into 2, but not quite. So technically, they still have only 1 ventricle if you want to get super technical, but it's pretty much separated into 2. So that means crocodiles, compared to all other reptiles, do the best job of keeping their oxygenated blood and their deoxygenated blood separate. Now, going back to our evolutionary family tree, reptiles share a common ancestor with dinosaurs. So we've got the dinosaur branch, we've got the reptile branch. We know that birds evolved from the dinosaur branch. So you can see how that evolution of the heart helped the birds to have that fully separated ventricle into 2 clear chambers, which I think is really fascinating. Now, even though crocodiles do have that full separation, or almost full separation I should say, and they do keep the oxygenated blood and the deoxygenated blood where it needs to be, they are still ectotherms. They are still considered to be cold-blooded animals. They can just maintain higher levels of metabolism, which means little Charlie here, if he was in the wild, could swim many thousands of kilometers if he needed to in search of food. So they can do a lot of activity. They are very powerful predators, but they do still need to bask in the sun to get warm. So they can't maintain their body temperature like a mammal or a bird. So that has been our little body and organ systems sneak peek into the cardiovascular system of lots of different groups of animals. So for me, I find it really fascinating that our hearts are very, very similar to a lot of other animals, but they are still a little bit different in each family group, which is really, really, really cool. If you guys do have any questions, please make sure you put them in the comments and I will happily answer them all for you. So they can be on the circulatory system, they can be on other body systems. You can just ask me general information about the animals. I will happily answer all your questions. A couple of reminders. Make sure you are subscribed to receive notifications for all the Reptile Encounters wildlife streams on our Facebook page. Make sure you are liking and following Reptile Encounters on Facebook. Make sure you are liking and subscribing Reptile Encounters on our YouTube channel. And if you do have any questions on our... Did I itch your foot there? I'm sorry, little Charlie. If you do have any questions on our wild school incursions or our wildlife streams for schools, please give our office a call, 1300 4-CROCS. And please tune in to our next wildlife stream at 2 p.m. We're doing a behind the scenes. So we will see you at 2 o'clock this afternoon. Thank you for joining me. My name's Cara. Bye.